Hello, dear students. Welcome to the discussion of electrostatics. This is the fourth lecture of the series. In this lecture, we will be discussing Coulomb's law, and some other terms like permittivity, permittivity vacuum, permittivity, relative permittivity, etc. Okay, Coulomb's law is the basic law of electrostatics. We have Gauss's theorem also, but that is not a basic one. It's a shortcut. Okay, you will study all those things in the coming classes. Okay, so we are going to the Coulomb's law. What is Coulomb's law? Coulombs. Coulomb's law. What is Coulomb's law? The full name is Coulomb's inverse square law. It's an inverse square law. Inverse square law. I will explain why it is called the inverse square law. Consider two charges, Q1 and Q2. There are two charges, Q1 and Q2. A charge is represented by the letters Q. Small q or capital Q you can use. Q means quantity of electric charge. Suppose R is the distance between these two charges. Then, according to Coulomb, the force between these two charges, the signs of the charges can be plus or minus. This can be plus or minus, and this also can be plus or minus, no problem. In Coulomb's law, we are finding how much is the force. What is the magnitude of the force? Coulomb explains about the magnitude of the force. Direction we can easily find, because if this charge is plus and this is plus, the force will be repulsive and it will be away from each other. If this charge is negative and the first one is positive itself, then what will happen? The force will be attractive. Q2 will attract Q1 to this side, and Q1 will attract Q2 to this side. The force will be attractive, and so on. So now we consider only the magnitude to explain Coulomb's law. Okay, so according to Coulomb's law, the force is directly proportional to the product of the charges. The force is directly proportional to product of the charges. That means if Q1 increases, the force increases. If Q2 increases, then also the force will increase. And force is inversely proportional to square of the distance, the square of this distance. That means as distance increases, force decreases, or as distance increases, force rapidly decreases. That we can reason it, because as distance increases, the force decreases. Okay, that we have seen the similar case in gravitation force, right? So together, by combining these two equations, you can write it as F proportional to, you have to multiply those things on the right hand side. Q1 Q2 into 1 by r square. So it is Q1 Q2 by r square. So this is the statement of Coulomb's law. The force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The force is directly proportional to product of the charges and it is inversely proportional to square of the distance between them. Okay, so let us read the statement of Coulomb's law. State Coulomb's inverse square law in electrostatics. This is a statement. You have to by heart the statement. Coulomb's law states that the electrostatic, what is that force? The force is called electrostatic force. The force between charges is called the electrostatic force. The electrostatic force between two stationary point charges. You have to note these points. Stationary means the charges are at rest. Point charges means the size of the charges are negligible. Charges are they have negligible size. Size is negligible, or sizes are negligible. Okay, then the Coulomb's law states that the electrostatic force between two stationary point charges is directly proportional to what? Directly proportional to the product of the magnitudes of the charges. You don't need to consider the signs of the charges. You just consider the magnitude of the charge. How many coulombs are the charges? Coulomb is SI unit of electric charge. Coulomb is the SI unit of electric charge. We have already discussed that. Okay, the Coulomb's the electrostatic force between the two stationary point charges is directly proportional to the what product of the magnitudes of the charges, and it is inversely proportional to and inversely proportional to square of the distance between them. Inversely proportional to square of the distance between. This is the Coulomb's law. Okay, so you have to by heart this statement. So here, to replace this proportionality sign, we can put a constant k. You are familiar with putting this constant to replace the proportionality sign. Okay, so this electrostatic force is k times q1 q2 by r square. Here, k has the constant k is a medium dependent constant. It depends on the medium, unlike gravitation force. In the case of gravitation, the gravitation force is given by g into m1 m2 by r square. You have studied in the 11th class. So this constant, the universal gravitational constant, it is called the universal gravitational constant. Why is it called the universal gravitational constant? Because it is same everywhere the universe. It is independent of the it is independent of the medium. The gravitational forces between two masses is the same, whether the medium is water, air, vacuum. This is a universal constant. But our k is not like that. K is not a universal constant. K is a constant which depends on the medium. So we express k as like this: 1 by 4 pi epsilon. This letter may be new for you. You have to read it as epsilon. 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 It's a Greek alphabet. Uh, read as epsilon. Okay. So what is epsilon here? Epsilon represents the permittivity of the medium. Permittivity of the medium. So epsilon represents the permittivity of the medium. Permittivity of the medium means how the force depends on the medium. You can just imagine like this: how the force depends on the medium. Okay, the dependence of force on the medium comes through epsilon. So epsilon is such a constant. Permittivity of the medium. Okay, we know that in common cases our medium is air, because air is around us. So for air, if air is the medium between the charges, I will write like that. If air is the medium between the charges, if air is the medium between the charges, that constant can be written as 1 by 4 pi epsilon 0. The constant is denoted as epsilon 0. What is this epsilon 0? The value of epsilon 0 is 8.854 into 10 to the power of minus 12 Coulomb square per Newton meter square. This is the constant with the units. Okay, this is a very, very small value. If you calculate 1 by 4 pi epsilon 0 by substituting the value of epsilon 0, you will get, you have to substitute this value here, and the pi is 22 by 7 or 3.14. So then you will get this number 9 into 10 raised to 9. The unit is Newton meter square per Coulomb square. Okay, so this is that constant. So what is epsilon 0? Permittivity of vacuum or free space. Vacuum, or you can say free space, or air. Okay, when we consider the permittivity of vacuum and air, there is no much difference. So we approximate the permittivity of air as the permittivity of vacuum. So for air, if air is the medium between the charges, I will write F air. Don't read it as F air. It's F air. F air. The force between the charges when they are placed in air, it's 1 by 4 pi epsilon 0 q1 q2 divided by r square. This is the force. Okay. You have studied the relative density. Relative density. Do you remember what is relative density? I will write it as rho r. Relative density is equal to density of a density of a medium, density of a medium divided by density of water. Okay, so to find the density of copper, the relative density of copper, relative density is also called specific gravity. Specific gravity. To find the relative density of copper, we have to do like this. This is the density of copper, kilogram per meter cube, and you have to divide this density of copper with the density of water, which is 1000 kilogram per meter cube. Then you will get a number which is 8.9. That is called the relative density of copper. Similarly, here we have a relative permittivity. Relative permittivity. What is relative permittivity? Permittivity of a medium divided by permittivity of vacuum is called the relative permittivity. Permittivity of a medium divided by permittivity of vacuum. You can say relative permittivity is the ratio of permittivity of a medium to the permittivity of vacuum. Okay, so you may write this relative. This is called the relative permittivity of a medium with respect to air or vacuum. So if you find the epsilon from here, permittivity of the media from here, you will get like this: epsilon r into epsilon 0, or epsilon 0 into epsilon r. Okay, like this. You will get the permittivity of a medium. Permittivity of any medium can be written like this. So this is the force between the charges when air is between the charges. Now, let me add one page. Okay. Now, for any medium other than vacuum or air, let water be the medium, then the permittivity changes. But the permittivity of the medium can be written as epsilon r into epsilon 0, or epsilon 0 into epsilon r. So the force when a medium is in between the charges, you can write that force as 1 by 4 pi epsilon into q1 q2 by r square, and this epsilon can be replaced by epsilon 0 epsilon r. Okay, r square. So here you can see that the quantity inside this loop is what? F air. The quantity inside the loop is F air. 1 by 4 pi epsilon 0 q1 q2 by r square is F air. So F air, and in the quantity outside the loop is epsilon r. So we can write this as an equation that is useful for doing some questions. F air divided by epsilon r. You have to by heart this formula. You have to by heart Coulomb's law, the statement. Okay, the equation of relative permittivity, which is epsilon r equal to epsilon by epsilon 0, all those things. This also is an important equation. So by heart this equation, write these formulas in formula book. Okay, now we have discussed only main three formulas, like quantization q is equal to ne. In the previous lectures we have discussed. Then here we have Coulomb's law, F is equal to 1 by 4 pi epsilon q1 q2 by r square, and the F medium is equal to F air by epsilon r. Okay, three formulas only. And you may add that formula for relative permittivities, which is epsilon r is equal to epsilon by epsilon so like this. You have to write the formulas in your formula book, so you can easily revise the formulas. Okay, now let us answer this question. Define dielectric constant of a medium. Dielectric constant is same as, it is another name of, dielectric constant is another name of relative permittivity. Dielectric constant is another name of relative permittivity. So what is dielectric constant? Relative permittivity, which is epsilon by epsilon r. So how can you write it in sentence? Relative dielectric constant may be defined as the ratio of permittivity of a medium to the, sorry, I have made a mistake. Permittivity of medium to the permittivity of vacuum. Okay, dielectric constant of a medium may be defined as the ratio of permittivity of a medium to the permittivity of vacuum. Does it have some unit? No, it's a unitless quantity, like relative density. It's a unitless quantity, unitless and dimensionless quantity. Okay, read this question. If the air medium between the two charges is replaced by water, what change you expect in the electrostatic force and why? So here there's a medium air between two charges, Q1 and Q2, which are separated by a distance r. So the force, F air, 1 by 4 pi epsilon 0 Q1 Q2 by r square, since air is a medium. If there is water, if these charges are kept in water, suppose these charges are kept in water, the system of charges are kept in water, then the equation changes. F medium, now water is a medium, is equal to 1 by 4 pi epsilon 0 epsilon r into Q1 Q2 by r square. How can we connect these equations? As I told you earlier, this is nothing but F air, and the quantity outside the loop is epsilon r. So using this equation, you can connect them. Okay, so we can say that F medium is F air divided by epsilon r. So when the here the permittivity of water is nearly 80 or 81, relative permittivity of water is nearly 80 or 81. So the force, what happens to the force? The force reduces, the force decreases when placed in water. The force decreases when placed in water because epsilon r, F medium is F air divided by epsilon r. So we have to divide F air with a number which is greater than 1, like 81. And so the force is reduced, the force is decreased. So you can write the answer. This is the explanation, everything is the explanation, but the answer is force is reduced. Force is reduced by a factor of epsilon r. Or if it is, if epsilon r is given, you can write that value 81. Okay, write Coulomb's law in vector form. Now we are going to write Coulomb's law in vector form. Okay, how can we write Coulomb's law in vector form? How can we write Coulomb's law in vector form? Okay, I will draw a diagram. There are two cases. Case one is force is attractive. Force is attractive means the charges are unlike charges. Unlike charges attract and like charges repel. Force is attractive. So then I will suppose this is Q1 and this is Q2. They are separated by a distance r, and I will mark the forces. Suppose one charge is positive and the other is negative. So there will be attraction. So Q1 will be attracted to the side of Q2. I will write the force on Q1 as the force experienced by Q1 as F12. And the force experienced by Q2, that also is attraction towards the side of Q1. It is F21. The force acting on 2, and it is given by Q1. Okay, force acting on Q1 is F12 and force acting on Q2 is F21. So here the distance is R, but I want to consider the distance as a vector. For that, if I consider distance from here to here, it is R12 because it's a vector drawn from 1 to 2, right? If I consider vector from the right to left, that means from Q2 to Q1, that distance I am representing that distance as a vector. Then it is R21, right? R21. Vector from 2 to 1. Vector from 2 to 1. The other one is vector from 1 to 2. Vector from 1 to 2. Okay. The other one is the vector from 2 to 1. So here, so when I write F12, how can I write F12 here? F12 is equal to 1 by 4 pi. Suppose air is the medium or vacuum is the medium. Q1, Q2 by R square. Or you can write R square is same as, you can write R12 square, no problem. But there is the modulus of R12 is equal to modulus of R21. So you can simply write it as R. But to show the direction, what is the direction of F12? It is to the side of 2. It is from charge 1 to charge 2. It is from charge 1 to charge 2. It is to the right from 1 to 2. To give that direction, I will write R12 cap. What is this R12 cap? Is a unit vector along vector R12. That means, what is the magnitude of unit vector? It is 1. That is why it is called unit vector. Okay, so R12 cap. This is the first equation for F12. And for F21, how can you write F21? The magnitude is the same. What is F21? The force acting on the second charge due to the first charge. The first charge attracts the second charge. So it F21 1 by 4 pi epsilon 0 Q1 Q2 by R square. There is no change in the magnitude, but the direction is opposite. What's the direction of F21? It is from 2 to 1. So I should write 2 1 cap. And from equation 1 and 2, you can simply understand, you know, this R12 cap and R21 cap has only one difference. They are opposite direction, but they are unit vectors, so magnitudes are same. So you may write this 1 by 4, the F21 as, this part is same. Instead of R21 cap, I will write R12 cap with a minus sign. So R21 is what? R21 cap is minus of R12 cap. Okay, so what did we get? F21 vector, F21 vector is equal to, if you take minus sign outside, the remaining thing is nothing. It is Q1 1 by 4 pi epsilon 0 Q1 Q2 by R square into R12 cap. So what is this quantity? This is nothing but F12. So minus of F12. So what do you get from this result? What we have got is F21 vector is equal to minus of F12 vector. It is like action is equal to equal and opposite to reaction. Action is equal to minus of reaction. Okay, so it is third law, Newton's third law. So you can say that Coulomb's law obeys Newton's third law. You can prove like this. Coulomb's law obeys Newton's third law. Okay, Coulomb's law obeys Newton's third law. Coulomb's law obeys Newton's third law. Okay. And if the force is, what was this case? Case 1, force is attractive. Attractive. When the forces are repulsive, the case is similar, very similar, very similar. When the forces are repulsive, let me add one more page. The second case, when force is repulsive, means the two charges are like charges. Q1 and Q2 are like charges. Let both of them are positive charges, or both are negative charges. Then what will be the direction of forces? The force on this Q1 will be away from that. Q2 will repel Q1 and Q1 will repel Q2. So this is the F12 vector. This is F21 vector. Okay. The force on the first charge due to the second. The other one is the force on the second charge due to the first. Okay. So here, if you write F12, you know this vector, the vector drawn from 1 to 2 is, the direction is R1 to cap. The vector drawn from 2 to 1 is R21 cap. Okay. So here you can see that F12 is in the direction of R21 cap. F12 is in the direction of R21 cap. That is the difference here. That is the difference here. So I will write it as 1 by 4 pi epsilon 0 Q1 Q2 by R square into what? R21 cap. So for F12 vector, we have to write R21 cap because it is a repulsion. And for F21 vector, 1 by 4 pi epsilon 0 Q1 and Q2 by R square into F21 is along the direction of R12. So I have to write R12 cap. As in the previous case, we can write F12 or F21 is equal to F21 vector is equal to minus of F12 or vice versa. Third law, Newton's third law. Okay, I think it is clear to you. The you may ask to show the Coulomb's law obeys Newton's third law. You can show like this. Otherwise, this is the vector form of Coulomb's law. This is the vector form of, these are the vector forms of Coulomb's law. Now we have to define one Coulomb. One Coulomb. Consider two charges, Q1, Q2. Suppose this Q1 is 1 Coulomb and Q2 also is 1 Coulomb. Both are positive. Let both are positive. Separated by a distance is equal to 1 meter. Then you know there will be repulsion between these two charges. If you write the repulsion, it is like this. The magnitude of the, if you write the magnitude of the force, it is like this, 1 by 4. Suppose air is a medium between the charges, then you can write 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Okay, this is the magnitude. What is the value of this? 9 into 10 raised to 9. You have to remember that value. 9 into 10 raised to 9 into, what is Q1 here? 1 Coulomb. Q2 is 1 Coulomb. What is distance? 1. So what do you get? It is 9 into 10 raised to 9 in SI units, Newton. Okay. So if 1 Coulomb charges are placed in vacuum or air at a separation of 1 meter, they will experience a repulsive force of 9 into 10 raised to 9 Newton. So you can define 1 Coulomb charge like this. 1 Coulomb is defined as, or 1 Coulomb charge is defined as that charge which when placed in a free space or vacuum, you can write vacuum also, which when placed in free space at a distance of 1 meter with an equal and similar charge. Okay, we are saying that when 1 Coulomb charge is placed in free space at a distance of 1 meter with an equal and similar charge, will repel, they will be repelled with a force of 9 into 10 raised to 9 Newton. So this is a difficult sentence, but this is the definition of 1 Coulomb charge. that we got from the equation. 1 coulomb is defined as that charge which will place in a free space at a distance of 1 meter with an equal and similar charge. Equal means both are 1 coulomb. Similar means both are positive. If one charge is positive, other should be positive. One charge is negative, other charge should be negative. Then only you can say they will repel. If one is positive, other is negative, they will attract. So if you want to say they will repel, you have to take one charge as positive, other as, sorry, both charges positive or both charges negative. Okay. So this is the definition of 1 coulomb charge. Okay. So this is the end of this lecture. Now we have studied Coulomb's law. Okay. Coulomb's law, the equation, and we wrote the equation in the case of vacuum. In the case of any other medium, we studied about relative permittivity, which is epsilon by epsilon r, and we we got an equation like this to compare the force in air and force in another medium. Okay. uh, we studied the statement. You have to by heart the statement. Then we uh, discussed the vector form of Coulomb's law. Vector form of Coulomb's law. Okay. And we defined 1 coulomb charge. So I conclude this video. Thanks for watching. We will meet in the next video uh, with another topic. Thank you.